All right, let's talk about the parallelogram for a minute. Let's go through the definition and the four key properties. What happens in this area is you learn different types of parallelograms, the square, the rectangle, the rhombus, and the parallelogram. And you learn their properties with them. And it starts to get confusing because there's a lot to remember. One of the things I'll say to you is the future shapes, the square, the rectangle, and the rhombus, are a type of parallelogram. So while they will gain new characteristics, they will all have these ones as well. So the definition of a parallelogram, first of all, is that it has two sets of opposite sides that are parallel. So you have this knowledge. In future questions, I will say that that's very important. You can use corresponding angles, alternate interior angles. You can use any of the parallelogram properties, parallel line properties, to find new angles and solve problems. You learn that you can prove it, but you also know that there is rotational symmetry of 180. Because it has rotational symmetry order 2, angle 180, when you turn the shape, this would land on this, and this side would land on this side. So opposite sides of all parallelograms will always be equal. There are many relationships that will get set up about knowing this and wanting to know this and so on, and they were just easy, that opposite sides are equal. Well, that idea of rotational symmetry would map this angle at 180 onto this one, and this angle onto this one. So we learn that the opposite angles of all parallelograms are equal to each other. The next one's a little tricky for some students to understand what it means. It says consecutive angles equal 180. Now, from this diagram, let's write that down. What we already know is this. What it means consecutive angles is the two that are next to each other. So it's telling us that these two add to 180. Now, why would that be? Well, you and I learned in a previous earlier time that if we had some parallel lines like this, can you kind of see the parallel lines like this? That these are called same side interiors, and they added to 180. So these are same side interiors. Well, if X and O here are same side interiors, we find that these are also same side interiors, and so are these, and so are these. So any two adjacent consecutive, actually not adjacent, but consecutive angles will add to 180 together. And then this one. Now diagonals are mostly new information to students. So, and they are what's most unique about the new shapes. So diagonals in this case definitely are not equal in size, definitely not perpendicular, but what they are is that they bisect each other. In other words, they cut the shape into equal parts like that. Now the goal of what's coming is for you to use that information to solve all kinds of different problems. So if I gave you this and told you it was a parallelogram, and let's say I put 30 degrees in this corner, let's say I put 50 degrees here, let's say I want to know this, I'd like to know this. I probably need to know a little more information. Let me just see what I can find. Let's do this. Let's do this as 20 down here. Actually, my belief is from this information, I'd be able to find any angle you want. Let me show you how. So I know that these lines are parallel. That's here. So this is alternate interior. 50 would be alternate interior to this angle. I found one. I also know that these lines are parallel going this way. And so this 30 would be alternate interior to X. So this would be 30 up here. Do you notice that this sums to 80 and this sums to 80 because opposite angles have to be equal? Let's see. This 20 would alternate interior into this corner. Now there's still some angles I don't know. So let's show you a few more tricks here. If this corner together equals 80, that means this corner together has to equal 100. Whoa, Patterson, where'd you come up with that? Well, consecutive angles have to add to 180. So this must be an 80 here. That would be one way to find that anyways. Another way to have done that is that you have a triangle. Well, let's keep moving for now, actually. So this is 50. So this guy here would be 130, and so would this be. I've almost found every angle, haven't I? I have 50 and 80. That leaves 50. Oh, actually, linear pair here, 50, 50, and so on. The key to this is to maintain these properties in your head while you're figuring them out. These guys get a little tricky, I'm going to just say that. Let's do something with length as well. So let's say we had a parallelogram, and let's say this is 2x and this is 15. Let's say this is 3y minus 2 and this is 40. Yeah, let's do that. Let's also do something in the inside here. So let's do, this is 6, and this is 2z. All right. If we're told this is a parallelogram, I would know that this side must equal this side. So I would solve 2x equals 15, x equals 7.5. Being a parallelogram, I would know this side equals this side. So 3y minus 2 equals 40. 3y equals 42. And y equals 14. 14. Now the last one is your diagonals in here, which would be 2z equals 6. Why do I know that? Because diagonals are bisectors. Diagonals bisect each other, and so z equals 3 would be the way to do that. Okay?